Now, in this video, we are going to discuss on the calculation of centroid on a composite body. The composite body is basically a body of irregular profile which can be defined with multiple series of simpler shapes. For example, this concrete barrier. It's a bit irregular and not a typical rectangular kind of shape. So, to ease our calculation for the centroid location, the profile of the composite body can be partitioned into simpler shapes like this. It may be constructed of 3 rectangles and it can be perfected with another 4 triangles. So, using the provided table, it will be quite easy to determine the centroid of each simple shapes. And looking back at the concrete barrier earlier, the centroid of each rectangles can be easily determined whereby it will be exactly at the middle of its width and height. On the other hand, the centroid of the triangle would be 1/3 from its corner like this. So every single shape will have its own centroid. The coordinates of the centroids can be represented with an x curve and y curve like this. By combining the centroids of each simple shapes, we can actually calculate the centroid of the entire body of the concrete barrier, whereby the symbol would be x bar and y bar. So, if you want to calculate the center of gravity, you can multiply the centroids, the x curve, y curve, z curve of each shapes with their weight. You sum it up and divide it with the total weight of each shape. Okay. Similarly, if you want to calculate for the center of area, you can multiply the centroids of each shapes with their area. Okay. You sum it up and divide it with the total area of each shape. Depends on what you're looking for lah. Now, let's look at this very simple example, okay? You are required to look for the location of the center of area for this particular boundary, the shaded boundary. So, if you recall the formula given earlier, then the location of the center can be determined by summation of the x curve multiplied with the area divided with the summation of the area of each single shapes. So, the same applies for the centroid of the y direction as well. Now, the shaded boundary is a kind of a composite body. Okay, so you can actually partition it into simpler shapes like this. Okay, there will be one triangle over here, and the second element will be a rectangle, and the third one will be a square. Okay, you can easily organize your data and information by constructing a table like this. Okay, the first column would be the segment or the simple shape. The second column would be the area of that shape. The third and the fourth column would be the centroid of the shape, which is the x curve and also the y curve. Okay, and the fifth column would be the multiplication of the area to the x curve, and the final column would be the multiplication of the area with the y curve. So all this information are the information necessary to calculate the centroid of the overall composite body. Since we have 3 shapes in our composite body, so we are going to add on another 3 rows to our table. Okay, now let's look at the first segment. It's a triangular shape, so the area of a triangular shape is half multiplied with the length and multiplied with the height. So half multiplied with 3 and 3, you will get a corresponding area to be 4.5 meters squared. The centroid of a triangular shape would be somewhere around here, whereby along the x-axis it would be about 1/3 from the length, which is 1/3 of 3 meter. Accordingly, along the y direction also it would be about 1/3 from its height of 3 meter. So if you plot the coordinate of the centroid of the segment 1, so the x curve or the coordinate along the x direction would be 1 meter, and the coordinate at the y direction or the y curve would be 1 meter. Okay, now let's repeat the same process for the second segment. The second segment is a rectangular shape and the area can be easily attained by multiplying the length to the height. Okay, so the length is 2 meter and the height is 3 meter. Okay, so you'll get the area of the second segment to be 6 meters squared. Okay, position of the centroid will be exactly in the middle of the rectangle. So therefore, the coordinate or the x curve of the centroid along the x direction would be half of 2 meter, which is 1. So accordingly, along the y direction will be half of its total height, which is half of 3. So therefore, the coordinate of y curve would be a fraction of 3 over 2. Okay, you can just leave the answer just like that. Okay, repeat the same process for the third segment. It's a square with the area of 1 multiplied with 1, so the area is 1 meter squared, and the position of the coordinate will be exactly in the middle of the segment. Okay, just that the x coordinate measured from the origin would be 2 plus with half of 1, which is 2 plus 0.5. So the x curve would be 2.5 meter. Okay, since the 2.5 meter is plotted in the negative x direction, so don't forget to put the negative symbol over here. Okay, so the x curve actually indicate the coordinate. Seems like I forgot to put the negative symbol in segment 2 as well. Okay, so anything within the negative directions, you have to put the negative symbol over there to indicate the coordinate. Okay, so remember, x curve and y curve is coordinate. And then the y curve, which is the coordinate of the centroid along the y direction, it will be 0.5 meter juga lah, exactly in the middle between the height. Okay, now filling up the information in the fourth column is quite easy. You just multiply the area with the respective coordinates. So A multiplied with the x curve, which is 4.5 multiplied with 1, you will get a corresponding value of 4.5. Okay. The same goes for the fifth column, whereby you multiply the A with the Y curve of 1 meter. So sama juga lah, the answer would be 4.5 as well. So you just quickly fill up the remaining rows with the multiplication of area to its respective coordinates. Now, the next information you need is you need to sum up the total area of the segments, okay? So, the total of the area for these three segments is 4.5 plus 6 plus 1, and you will get a value of 11.5. You also need to get the summation of the AX curve. So total up 4.5 minus 6 minus 2.5, and you will get a summation of negative 4. Okay, and you also sum up the summation of AY curve. So 4.5 plus 9 plus 0.5, you will get a total value of 14. Okay, now we have enough information to calculate the centroid of the entire area. Okay, so the x bar is equivalent to summation of x curve A divided with summation of A. So the summation of x curve A, we calculate it to be negative 4, and the summation of A is 11.5. So you just divide these two values together, and you will get a corresponding coordinate of negative 0.348 meter. Okay, you do the same for the y bar as well. Okay, whereby the y bar, the summation of y curve and A is 14, and the summation of A is 11.5. So you will get a corresponding value of 1.217 meter. So what does this mean? This means that if you are to plot the centroid of the area in the diagram shown, so along the x direction, the coordinate or the position, it would be negative 0.348, okay, to the left side, and the direction along the y axis would be 1.17 meters. So this is the expected centroid of this particular area. Now let's look at another interesting example. Okay, so you are required to find the centroid of area of this particular boundary, the shaded boundary. Okay, so accordingly, I can divide it into simple shapes like this. Okay, there would be a square, and this would be my first segment, and then there would be a triangle shape, and this would be my second segment, and then I'm going to use a different color to indicate the item that I need to deduct. Okay, so this is a semicircle which must not be included in my calculation. So this is segment number 3, and the segment number 4 is another rectangle. Again, the area is something that I should not include in my calculation. Let me just quickly redraw every segment with its corresponding dimensions. Okay, so 1, 2, 3, 4, and the first segment is a rectangle actually, with a length of 120 millimeter, and the height is a total of 40 plus 20 is 100 meter. Okay, the second segment is a triangle with a height of 100 and the length of 60. Okay, the third item is a semicircle with a radius of 30, and the fourth segment is actually another rectangle with a dimension of 20 by 40. Okay, now let us extract important information from every segment. Okay, so the first segment is a rectangle. The area of the segment is 120 multiplied with 100. You will get the area to be 12,000 millimeters squared. Okay, the centroid of this shape, the x curve, would be 120 divided with 2, which is 60, and the y curve, or the centroid along the y direction, would be 100 divided with 2, so what will be 50. Okay, now you also need to find the multiplication of x curve with a. So 60 multiplied with 12,000, you get a value of 720,000. And the y curve multiplied with a, you get a value of 600,000. Okay, now let's move on to the second segment. The second segment is a triangle. So the area of this triangle would be setengah kali tapak kali tinggi. So half multiplied with 60 multiplied with 100, you get a value of 3,000 millimeters squared. The x curve, okay, the position of the centroid would be 1/3 from the length of 60. So 1/3 of 60, it would be 20 mm. Okay, but don't forget the x curve is actually a coordinate. So 20 mm plus with the coordinate from the origin, the distance from the origin, which is 120. So the x curve would be 140. Okay, and then the coordinate of the centroid along the y curve would be 1/3 of 100. I'll just remain the answer as it is lah. Okay, accordingly I have to calculate the value of x curve multiplied with a. So 140 multiplied with 3,000, you will get 420,000, and then the y curve multiplied with a, 1/3 of 100 multiplied with 3,000, I will get a value of 100,000. Okay, so as for the third segment, this blue colored shape of a semicircle, remember we need it to deduct, but anyway, let's just calculate the information that we need. Okay, accordingly, the area of a circle is pi r squared. So for a semicircle, it will be half pi r squared. Okay, so our r in this case is 30. Just substitute the value and we'll get a value of 1413.9. Okay, I think I missed out the square over there, square over the 30 too. And then the x curve would be 60. Okay, 60 from the origin, and the coordinate of the y curve, the centroid of the y curve, okay, remember for a semicircle you refer to the table. Okay, the centroid along the y direction would be 4r over 3 pi. Okay, if you are not sure what is the centroid of a certain shape, you refer to the table given in the lecture slide. Okay, so you just substitute the appropriate value and you will get a corresponding y curve to be 12.73. Okay, you just proceed with multiplying the x curve with the area and also the y curve with the area lah. And then you proceed attaining the information for segment 4, which is a normal rectangular shape. Okay, so again, don't forget that item 4 is the item that you need to deduct. Okay, you try to do this on your own. I'm going to fast forward this particular part. Look for the a value, the x curve, and also the y curve, as well as the multiplication of x curve with a and y curve with a. Okay, now that you have collected all the necessary information, the next step is probably it is best for you to organize all the data in an appropriate table. Okay, so the first column would be the segment or the shape that you have partitioned with, and then the next column would be the total area of each single shape. The third column would be the x curve multiplied with a, and the final column would be the y curve multiplied with a. Okay, there should be an additional 4 rows to represent the 4 shapes that you have partitioned it with. Okay, for the second column, you fill up with the area value. Okay, for shape 1 or segment 1, the area is 12,000. For shape 2, the area is 3,000. Okay, for shape 3, remember, you are deducting this area from the calculation. Okay, because dia ada lubang kat situ kan. So, therefore, the area should be negative value. Okay, don't forget that. Anything that you need to deduct, you have to put negative in front of it. So, it become, instead of 1413.9, it will become negative 1413.9. Okay, accordingly, segment 4 also needs to be deducted as well. So you include the negative notation in front of the area. As for the third and the fourth column, you can put in the information on the multiplication of area to respective coordinates. Okay, so for the first segment, x curve A is 720,000, the y curve A is 600,000. For the second segment, XA is 420,000, the Y curve A is 100,000. Okay, now remember, for the third segment, you are actually deducting it. So the A value for the third segment is a negative value. So negative multiplied with the X curve of positive, it will become negative 84,834. Okay, don't forget that negative value. And then the Y curve A also is multiplied with a negative A value, kan, supposedly. So therefore, instead of 17,000 something, it will become negative 17,998. Okay, so the same goes with segment form. As you are deducting that particular area, so your area is in a negative notation, so therefore the X curve and A, bila multiply with a negative, it will become negative as well. Okay, when that is done, you need to sum up all the upper values in the column. Okay, so the summation of area would be 12,000 plus 3,000 minus 1413.9 and minus 800, you get 12,786.1. Okay, accordingly, the summation of X curve A, okay, you just tambah tolak all the values there, you will get a value of 959,166, and the summation of Y curve A would be 650,000. Now all the information is ready, you can proceed to find the coordinates of the centroid. Okay, so x bar is equals to summation of x curve multiplied with A divided with summation of A. So we already calculated the x curve multiplied with A is 959.166 divided with the summation of A to be 12,786. So we will get a corresponding value of 75.02 millimeter. Okay, accordingly, you do the same for the Y bar as well. So Y bar multiplied with A, the total summation is 650,000 divided with the summation of A, which is 12,786. You will get the Y coordinate of 50.84 mm. Okay, so that is all. That is the centroid of the boundary given. Okay, dah siap. Kalau sebelum ni, we are locating the center of area. So now we are going to use the same formula to calculate the center of mass pula. Okay, so stay tuned.